So what I want you guys to do is you have to find at least 2 other people to be in your group. Actually, there'll be a group of 4 and a group of 3. You have to go around the room and find people that have either similar, like all 3 of you have to have something in common. So like it has to be either like a similarity or your same clothing or same birthday month or something like that. So like everyone in your group has to have something similar, and then you're gonna tell me what that similar thing is. And go. Group, what was your commonality?
Our math.
Your math. Love it. For this group, what was y'all's common thing?
We all play basketball.
Yes, love it. Love it. Okay, so I'm gonna give you guys one whiteboard for your group, because I kind of want to see what you guys know about energy waves. This is what the experiment is about today. So, first thing I want you guys to think about or discuss is what kind of waves are there. So, for example, there's sound waves. So, what kind of different waves can you guys come up with?
Okay. Like as a group or?
As a group.
Okay.
Come up with.
Okay, we have sound waves, electromagnetic waves, microwaves, light waves, color waves, UV rays, radiation, radio waves.
Yes, awesome answers. Taylor's group.
Really?
Oh, I just kidding.
We have ocean waves, gamma waves, tidal waves, sound waves, emotion waves, solar waves, and radio waves.
Awesome. So you guys know a lot about waves already, probably more than you think. So the next question I want you guys to do on your boards is, what is an energy wave? Question for this experiment is, what are the characteristics of energy waves? So the first question I asked you guys are, what kind of waves are there? And you guys listed a lot more than mine. There's ocean waves, sound waves, I heard you guys say gamma waves, electromagnetic waves, and mechanical waves, which is actually kind of what we're doing here as well. And then I asked you guys, what is an energy waves? These are just waves as a result of energy being transferred through something. So energy has to be transferred, or force has to be applied for the waves to actually result. So in this lab, we will learn about the characteristics of energy waves and how energy can move. This simple machine right here that you guys see, which you guys will all create, will demonstrate how energy moves through something and forms a pattern of movements. So, with that being said, if I could get you guys to come up and get your materials, you'll need 1 bag of marshmallows, bag of sticks, and tape. See this picture right here in the middle? You guys are gonna lay them about that width apart, maybe like 2 or 3 fingers apart. And then yeah, after that we'll go from there.
Sorry.
It should. It's not over.
Noah, can you pull it over a little bit? There you go. It'll be fine. We'll live.
Can we do another strip?
Yeah, we can always do that.
Oh, it's dragging. Like, just make sure it's pulled so that it's
And gravity sound waves aren't perfect.
Exactly.
Next step, we get to grab our marshmallows and we get to put 1 marshmallow on each end of your skewers. Just make sure that it doesn't, the skewer doesn't poke through the marshmallow. Yes, Princess. Yes, afterward. Okay. Yeah, they're pulling really hard.
That works.
Because I'm having mine a little off the edge like hers. Oh, wait, maybe not.
Oh, turn to the second page with me. Okay, so we just finished step 5 and step 6. So if you guys look, I put 7, 8, and 9 in different colors for you guys because it corresponds to the table that you guys are going to do right now. Okay, if everyone can look up here real quick. So the first thing you guys are going to do, step 7 says tap a marshmallow at one end and watch the wave ripple down the tape. And then in the data section, you guys are going to draw what that wave looked like. So if you guys look up here, I tried to demonstrate this for you guys as best as possible. But basically, you just tap it, and it's supposed to, I guess I didn't do it that hard. This side is better. and then you guys are gonna draw what wave it created. Then the second time, you guys are going to tap it a little harder than you did the original time. And then the third time, you guys are gonna tap it softly. And you can draw what the wave looked like in the data table.
Let me see it, do it again.
Okay, background music.
Dun, 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 dun.
Happy pictures, guys.
Oh, man.
We hit it on both sides. Okay.
Okay, so if I hit it lightly, let's
Oh, that looks nice.
see. Let's see if I can do it more. There you go.
This side on my side.
There you go. That was a good one.
Hold it taller.
It'd be pretty cool though, because when I hit it from the middle, it both like went to like different ends type thing.
You can do it.
Okay,
That's
I'm
so
gonna go
cool.
draw my pictures.
Characteristics of an energy wave. Olga, what did you put down?
Okay. Princess is raising her hand.
Oh, back there. I'm sorry.
That waves need energy in order to move.
Yes, awesome. Anyone else have something different? Yes, Princess.
They move in like the ripple movement.
Yes, they do move in a ripple movement. Okay, those are awesome answers. Number 2, which of the waves made the highest crest and why?
The hardest hit.
The hardest hit, right? Why was it the hardest hit?
Because of the amount of energy put into it.
Yes, the amount of energy, it had the most force applied to it. So then, which of the waves, number 3, which of the waves that you made had the lowest crest and why? It was the softest, right? Because not a lot of energy was applied to it. And the last one, if you wanted to increase the frequency of the waves you made, what would you have to do? This could have been an answer like you maybe altered the model, or you applied way more pressure than you did before. Any answer like that would have been. Did anyone have anything different? Hit harder. Right, awesome. Okay guys, that was your experiment.